Infrasound occurs where large masses are in motion. This happens in nature, with avalanches and earthquakes, for instance. But infrasound also arises through technology and industry. It's caused by large machines and blasting. Even wind turbines generate infrasound whenever their blades rotate. In a densely populated country like Germany, where wind farms border on residential areas, many people are robbed of their sleep.
It's worst when I lie in bed at night. After 5 or 10 minutes, I feel kind of dizzy. My heart starts to race and I get this massive ringing in my ears. To some extent, I also feel claustrophobic and stressed.
Insa Bock and Hermann Olderwurtel live in East Frisia, near the town of Esens. Located scarcely 700 meters from their home is a wind farm with a few dozen wind turbines. Since they function even at low wind speeds, the wind park is in operation virtually 24/7.
If you sleep here for 4 or 5 days, you feel like you've been out drinking for a whole week. It's that bad. You get these total mental blackouts. It's even happened to me on the phone. I couldn't believe it. But if I'm out and about, or if I go away for a few days, I'm as right as rain again.
At first it wasn't certain what was causing the health issues. Wind farms have existed here for more than 20 years, so they didn't seem to be the problem.
It took a while for us to realize that our health problems were being caused by wind power. Even we didn't believe it at first. We'd always had a small wind farm on our doorstep with 52 units.
We found them annoying. Sometimes they were so loud that we could hear them very clearly. But it's not as if the noise made us feel ill.
Similar to other people living next to wind farms, Insa Bock and Hermann Olderwurtel's problems were the result of repowering. That's when small wind turbines are replaced with bigger, more efficient models. It's a development welcomed by the German Environment Agency as part of energy transition. Officials here are not overly concerned at the infrasound from wind farms. They refer to tests carried out in the state of Baden-Württemberg.
These tests showed that when a wind farm is situated around 700 meters from a residential area, the infrasound from it is drowned out by background noise. In other words, a perfectly normal noise level arises from which it is no longer possible to filter out the specific features of infrasound.
This is what the situation looks like in chart form. From a distance of 700 meters, the infrasound from wind farms, shown here in red, can no longer be distinguished from the infrasound of the background noise, shown in green. The red graph has no peaks, no upward deflections. Infrasound is also measured in Bavaria. However, in order to identify possible explosions from nuclear weapons. Here, the Federal Institute for Geosciences and Natural Resources, the BGR, operates a measuring station. The I-26DE on behalf of the German government. The I-26DE is part of an international monitoring network designed to ensure that the terms of the Comprehensive Nuclear Test Ban Treaty are observed. The BGR achieves this with ultra-sensitive measuring systems. Looking more like showerheads than high-tech equipment, the inlets for the infrasound are located close to the ground where the rushing of the wind is least noticeable. Wind noise would affect the readings. The heart of the system is located a few meters underground. Garden hoses conduct the infrasound signals from the various inlets to a microbarometer. It measures minute pressure differences, the infrasound.
The measuring systems we have can determine the difference in air pressure between the upper and lower surfaces of a sheet of paper, even down to 1/40th of its thickness. That's how accurate our measuring systems are.
Extremely precise and thus also sensitive to infrasound signals generated by technical sources.
The Lake Moldau hydroelectric power station is located nearby. When a lot of water is released, that's also a factor. Wind farms are another source we know about.
So the infrasound from wind farms could affect the measurements taken by the I-26DE station. Because of this, back in 2004, the BGR examined the infrasound emissions from a single wind turbine. The scientists were mainly interested in assessing how far from the wind turbine it would still be possible to register infrasound emissions. Their measurements were analyzed at the BGR's National Data Center. Last Serrana comments on the frequency spectrum.
At low frequencies, our infrasound sensors picked up very clear signals from the wind turbine. Every time the blade passes the tower, large air volumes are compressed and sheared. This signal produces an infrasound signature, which we refer to as blade pass harmonics.
The blade pass harmonics of the wind turbine are individual frequencies. They emerge from the background noise with a distinctly higher acoustic pressure level, in other words, with more energy. Last Serrana explains.
If we follow the blue line with the mouse, that is the background noise. The distinctive elements of it here represent the contribution from the wind energy plant, the blade passing harmonics, when the blade passes the tower and generates an infrasound signal.
The wind turbine studied in 2004 was very small, barely 0.2 megawatts. For bigger wind farms, the scientists made a model calculation.
It takes us to a dimension where we can say that a 5-megawatt wind turbine would possibly generate a detectable infrasound signal even from a distance of 20 kilometers.
20 kilometers? But didn't they claim at the German Environment Agency that the infrasound emissions from wind energy plants are already lost in the background noise from a distance of 700 meters? So how can this huge difference be explained?
It's customary in acoustics to focus on bands, in other words, on groups of frequencies and not on the individual frequencies.
Just how this affects the data can be explained with different curves. The blue line represents the unembellished data and shows clear peaks.
If I focused on bands, I'd have a red curve here, with the peaks quite clearly evened out.
Thus, a graph flattened to such a degree provided the German Environment Agency with the argument that infrasound from wind farms is swallowed up by the background noise. Back to East Frisia. The house where Insa Bock and Hermann Oldewurtel live is both their home and their workplace. So selling it is out of the question. After initially promising to carry out measurements, the authorities responsible then declined.
We were informed that it would not be possible to carry out the tests at the time because the wind direction and wind strengths were not right.
Left in the lurch by the authorities, the couple commissioned the measurements themselves. They were carried out by expert Sven Johansson. Amongst other things, he used a vibration sensor because wind power plants also generate structure-borne sound. In other words, vibrations. Johansen compared the structure-borne sound pattern of the wind farm with that of the house.
It's like comparing fingerprints. You can prove which source something was triggered off by. In this case, we suspected the wind turbine.
Microphones measure the interior and outside areas. A microbarometer records minute air pressure fluctuations. All the appliances are synchronized to register infrasound and structure-borne sound simultaneously.
When powerful vibrations occur, as a rule, even minimal acoustic pressure in the airborne noise range is sufficient to cause discomfort. If there were no vibrations, the acoustic pressure could be a bit higher before it had this effect. So here we have interaction between structure-borne sound and normal airborne noise. That's why it's important to look at both at the same time.
Vibrations then increase sensitivity to infrasound, an additional burden for residents.
When I was lying in bed, I actually noticed the vibrations on the mattress. I had this strange feeling that something was wrong. Then, in the half light, I clearly saw the mattress move several centimeters. When the buzzing starts, it's like you were in a beehive. You just need to put your hand on the wall of the house and feel the vibrations. When it's really windy, the dog also feels the vibrations. It becomes restless. Then its favorite sleeping spot is in the wardrobe. Even if the door is closed, the dog will open it and climb in. That way, I think, it is no longer lying directly on the vibrations.
Sven Johansen also experienced the occurrence of vibrations.
The measurements showed a clear load in the form of powerful vibrations. We even noticed this ourselves when we were standing next to the house. To a certain extent, our technical measuring equipment also detected these vibrations inside the house.
Along with the vibrations, Johansen also registered a distinct infrasound load.
Extremely high infrasound levels were also detectable inside the house. To some extent, the acoustic pressure levels were even higher than in the outdoor area.
A survey by the authorities would have produced a different result, because it would have been performed according to DIN 45680. So the infrasound range would have been largely ignored and individual frequencies combined, thus smoothing off any peaks. The basic problem with this DIN is its simple assumption that anything below 20 Hz is imperceptible to the human ear. But there are justified doubts as to whether this is true. Professor Alex Salt works at the Washington School of Medicine in St. Louis in the United States. He is an internationally recognized expert on the physiology of the inner ear, and for some time now on the fact that the ear reacts to infrasound. It's an observation Salt and his team made more by chance in carrying out research into a disease of the inner ear. The doctors used infrasound to test how the diseased ear reacts to external stimuli.
Yes, it is. Okay. Yeah, so usually in surgery
we discovered that if you went down to very, very low frequencies, your results got better. So instead of having a sound you can hear like 30, 40 hertz, we went down and down and down, and we discovered even 5 hertz gave us lovely results.
The researchers wanted to get to the bottom of this surprising discovery. Why did the ear react to the signal even though it was inaudible? The answer lies in the complex anatomy of our ear, which, amongst other things, is equipped with 2 different types of sensory hair cells.
When a human is exposed to infrasound, that sound is going to go into their ear, it's going to stimulate their outer hair cells, it's not going to stimulate their inner hair cells, which are the ones they're hearing through. So they don't hear the sound at all, but there's still electrical responses in the ear to the sound, and that is still stimulating another pathway.
Based on his own observations and on an intensive study of specialized literature, Saul's findings are regarded by colleagues as undisputed, but that is not the case outside the world of science.
Lawyers who are on the advisors to the wind turbine people are extremely against this paper. They have given us a hard time for many years. I mean, we get trashed in lawsuits about how this is not possible and all this sort of thing. But somehow the scientists disagree with this. I think if you want to be biased, it's all to do with bias and money, I'm afraid.
For Professor Saul, the scientific questions concerning infrasound and human perception have by no means been fully answered. That's why he considers it important for more research to be carried out in this field. And that is precisely what is happening at Medical Center Hamburg-Eppendorf. Does infrasound affect the sleep and the mental capacity of human beings? An experiment, it is hoped, will provide answers. Clinical psychologist Dr. Leonie Ascone is installing loudspeakers in the rooms where test persons will be sleeping. The volunteers in the infrasound test group will be exposed to low-frequency sound for 4 weeks. The exposure will take place at night, with 90 decibels, a relatively high intensity. Before and after each test phase, the volunteers will be subjected to complex examinations, like a hearing test, and their reaction times recorded. The aim is to show what effect 4 weeks of exposure to infrasound has on the test persons. This study is the continuation of an earlier experiment. Scientist Professor Simone Kühn and her colleagues had exposed test persons to brief infrasound signals below the auditory threshold. In other words, sound they couldn't hear. The researchers then took a look at what happened in the brain.
What was interesting to note was that conditions with infrasound exposure close to the auditory threshold are somehow special. Intense activity took place in the anterior cingulum, a region of the brain which deals primarily with conflict situations, and also in the right amygdala, the region which is linked to stress management.
So, of all things, infrasound activates regions of the brain which normally manage stress. But it's not quite clear why.
We've also speculated that if you consciously hear something and realize there is something, you might block it out and say, I'm going to ignore that. But with things that are semi-perceptible, you don't have the ability to say, I'm going to ignore it. That's our theory.
So what we consciously hear can be assessed and, if necessary, ignored. But things that are only perceived subliminally, in other words subconsciously, generate stress and perhaps even fear. Someone who knows all about this is John B. Alexander, a former US Army colonel. He fought in Vietnam, became a member of the US Special Forces, and later he headed a department which focused on the development of unorthodox weapons.
This was powerful enough to completely blow the front end off a...
After the 1980s, at the latest, they included infrasound.
The first question was, are the effects that we're reading about real? And what you found is, yes, there were some people who were physiological affected. They were nauseous, they would get dizzy. There were some who had psychological issues, fear factors, inability to think kinds of things.
Effects, so the US military thought, that could be used well against an enemy. Prototype infrasound weapons of monstrous dimensions were then developed. Along with infrasound test chambers for animal experiments using rhesus monkeys. Other powers also expected great things from infrasound as a weapon.
Remember, when we started, we're talking 1980s, we're talking the bad old days, so we're talking the Soviet Union still exists, getting data out of Soviet research was extraordinarily difficult, but there were reports like controlled offensive behavior the DIA had that suggested that they were looking in that area. Our experience with the Chinese had been the same. They had looked across a wide range of technologies.
In the mid-2000s, at the latest, the idea of putting infrasound to military use was abandoned. The problem was the technology and the fact that infrasound does not affect everyone in the same way. For military commanders, that is unacceptable.
We found that, some people are affected dramatically, some people affected a little bit, and others not at all. From a weapons perspective, I shoot a bullet, I know what it's going to do to your body. As a commander, if you're going to have a weapon, you want something that when I pull the trigger, I know exactly what the effects are going to be, or can have a pretty close approximation.
The military has lost interest in infrasound, but medicine hasn't. Inaudible sound is attracting more and more research. Professor Christian Fahl is Director of Cardiac, Thoracic and Vascular Surgery at Mainz University Medical Center. Over the last 2 years, he and his team have devoted their research to the subject of infrasound. The focus is on the acute effects. The researchers are studying human heart muscle fibers. For this experiment, 2 fibers from the same patient are isolated. Only a few millimeters in size, the specimens are still alive. They are secured in 2 identical pieces of equipment. One will serve as a control, the other will be exposed to infrasound in the form of a 16 Hz frequency for 1 hour. The aim is to measure how the strength of the heart muscle fiber changes under the influence of infrasound. This is already the 3rd series of tests carried out by the work group. 2 earlier series have already been concluded.
We can definitely say that under these acute conditions, infrasound really does have a distinct effect on heart muscle tissue. Both series of tests have revealed a clear reduction in heart muscle strength.
Here in the laboratory too, the low-frequency sound cannot be heard, at least not consciously. It becomes visible when Dr. Rayan Shaban holds a sheet of paper in front of the loudspeaker. It is not yet clear just how infrasound manages to reduce the strength of the heart muscle, but one theory has already been put forward.
Think of a rowing boat with rowers in it. They are the cross bridges of the muscle. If this rowing boat is now exposed to an infrasound signal and suddenly starts to shake, if it were an 8 maybe, 4 of the crew would continue rowing, but the 4 others would get out of step, and in a jiffy the boat would lose speed.
What causes the rowing boat, or to be more accurate, the heart muscle, to get out of step is the energy of the infrasound.
Whether we hear it or not, every form of energy has physical effects, and infrasound is particularly dangerous because we don't hear it.
It is the duty of the federal government to protect its citizens from harmful environmental influences. The Federal Emissions Control Act stipulates how this has to happen and to what extent. First and foremost, the Act refers to significant influences.
The Act does not claim to cover every type of negative influence, so there can most certainly be cases where, for instance, someone feels affected by a source of noise in a way or to a degree that the Act does not cover. When a law is made, the legislature always leaves a small area which the law does not cover, and this is something citizens simply have to accept.
Simply accept? That is no option for Insa Bock and Hermann Oldewotel. They feel left in the lurch by politicians, betrayed in fact.
They show absolutely no consideration for nearby residents. They just make sure that wind park operators are fine, that their wind farms are approved and they can build them and make profit, with taxpayers' money, of course, because we also contribute to all this subsidized electricity.
The two seek respite on a camping site far enough away from their house and the wind farm. This is where they spend their evenings, but especially the nights, in order to get some sleep.
When I reflect on everything we have read so far, I believe that if we are not careful, we could turn into a land of insomnia, or of tired citizens who are exposed to signals they cannot hear, and thus cannot protect themselves against.
Insomnia, heart problems, perception disorders, dizziness. These are just a few of the disease symptoms that can be caused by infrasound. Doctors believe that between 10 and 30% of people react to it. That means several million in Germany alone. Nevertheless, the mass experiment with wind power continues unabated.